Electrostatic potential and capacitance. An electrostatic force is a force caused by stationary electric charges or fields. The electrostatic force is caused by the transfer of electrons in objects. So now, what is electrostatic? Electrostatic is a branch of physics which deals with characteristics electric charges which are slow moving or stationary. Examples of electrostatic phenomenon are laser machine and photocopier, spontaneous explosion of grain silos, attraction of paper to a charger scale. So these are the electrostatic phenomenon. Electrostatic charge. So what is the cause of electrostatic charge? Static electricity is an imbalance of electric charges within or on the surface of a material. The charge remains until it is able to move away by means of an electric current or electrical discharge. Static electricity is named in contrast with current electricity, which flows through wires or other conductors and transmits energy. A static electric charge can be created whenever two surfaces contact or separate, and at least one of the surfaces has a high resistance to electric current and is therefore an electrical insulator. The effects of static electricity are familiar to most people because people can feel, hear, and even see the spark as the excess charge is neutralized when brought close to a large electrical conductor or a region which an excess charge of the opposite polarity. The familiar phenomenon of static shock, more specifically an electrostatic discharge, is caused by the neutralization of charge. So basically there are two types of electrostatic charges. One is positive charge, the second one is negative charge. Then what is electrostatic potential? Inside a field, the amount of work need to move a unit positive charge from one initial point to any specified point without producing any acceleration is known as electrostatic potential, or also known as electric potential and electric field potential. The formula for electric potential V is equal to work done by charge. So V is equal to W by Q. Electrostatic potential is denoted by V and it is a scalar quantity. Electrostatic potential can be measured in volts. Then your Coulomb's law. The Coulomb's law of electrostatic is also known as Coulomb's inverse square law, which describes the forces acting between the static electrically charged particles. So F is equal to Q1 Q2 by 4 pi E0 R square. So this is your Coulomb's law. Now let us discuss about the laws that governs electrostatics. First law. The first law of electrostatics states that like charges repel each other while unlike charges attract each other. That is, two positive charges will repel each other while one positive and one negative charge will attract each other. So you can refer to this image. Then second law. The second law states that the properties exerted between two point charges is directly proportional to the product of their strengths, is inversely proportional to the square of the distance between them, and is inversely proportional to the absolute permittivity of the surrounding medium. So these are the two laws that governs electrostatics. Now, what is a capacitor? Capacitor, also known as condenser, is two terminal electric components which has ability or capacity to store energy in the form of electric charge. The storing capacity of capacitance vary from small storage to high storage. The ability of a capacitor to store the energy in form of electric charge is known as capacitance. Capacitance can be described as the storing ability of one capacitor and it is measured in farads. Capacitor in series. Capacitor C1 and C2 are connected in series. So you can refer to this image. When the capacitors are connected serially, then the total capacitance, that is C total, is less than any one of the capacitors' capacitance. So we can calculate the capacitance in series like C total is equal to 1 by 1 by C1 plus 1 by C2 plus 1 by C3 up to 1 by Cn. This is the formula of capacitance in series. The second one is capacitance in parallel. Capacitors C1 and C2 are connected in parallel. You can refer to this image. Here C1 and C2 are connected in parallel. When the capacitors are connected parallel, then the total capacitance, that is C total, is any one of the capacitors capacitance. So mathematically we can calculate the parallel capacitance as C total is equal to C1 plus C2 plus C3 up to Cn. So guys, we just discussed about the electrostatic potential and the capacitance. For detailed study of this chapter, visit to our website www.syft.in. Thanks for watching us.